Hello, I am Agent Delta. Before I start this video, I want to say that I admire and am very grateful to all the armed forces of the United States for their service and the way they have fought for freedom. I also admire all the world champion shooters for what they have accomplished in the sport. Now, let me say that I am not a Delta Force or a Navy SEAL. I am an engineer who graduated from one of the best engineering universities in the United States. And I have been shooting since I was 7 years old. Some time ago, I wrote a book called Pistol Personal Defense that is selling in Amazon.com and is very controversial. I know this is going to be a very controversial video too, but I decided to make it when I realized that more than 90% of the instructors that are teaching now are teaching how to hold the pistol wrong. One of my friends wrote in one forum about the book, and somebody answered, "What does an engineer knows about guns?" Well, I think I can answer that. And let's have one thing very clear. Engineers design guns and analyze the forces that they are subject to much better than any Delta Force, Navy SEAL, or World Champion. Now, let's see the forces acting on a pistol when you shoot, and how to hold the pistol later. All forces shown in the graph are resultant forces. Notice the coordinate axes, X, Y, and Z, drawn on the figure right here. The x-axis is the horizontal axis. The y-axis is the vertical axis. And the z-axis is the axis perpendicular to the graph. Fx1 is the recoil force minus the force of the recoil spring. Fx5 is the force of the trigger press right here. Fh1 is the force of the shooting hand with its component Fx2 and Fy1 right here. Fh2 is the force of the support hand with its component Fx3 and Fy2 right here. Fz1 and Fz2 are the forces of the palm of the hands on the sides of the handle. Fx4, the resultant of the forces of the finger of both hands on the front strap. Cm is the approximate location of the center of mass. Fy3 is the weight of the gun right here. When you shoot the gun, after you press the trigger straight back, the bullet leaves the barrel and the slide moves back. The gun will also try to move back, and this will be opposed by the recoil spring and the hands on the back strap right here. Notice
that movement is on the XY plane only. Also, when the slide moves back, when it gets to the shooting hand, a torque is produced that moves the barrel up. This torque will be opposed by the fingers holding the gun on the front strap. Notice that the movement is on the XY plane only. These are the only forces produced by the recoil. There is no force in the Z-axis. If you put any major force on the Z-axis with intention of creating friction forces that help with the recoil, these forces are going to be detrimental to the accuracy because the friction forces are a small fraction of any force that you apply in the Z-axis. Any imbalance of the forces FZ1 and FZ2 on the Z-axis is going to move the gun left or right. Now, let's take a look at the way you should hold the gun to oppose the recoil. The shooting hand should go as high as possible in the tank. The index finger outside the trigger and the other fingers wrapping around the handle. Most instructors explain this part right. The support hand is the big pro. Look at the majority of the instructors in YouTube. They flag the thumb like this and tell everybody to fill the empty space with the support hand. That is wrong. We saw before that there are no forces from the recoil in the Z-axis. Why introduce one more variable that can affect the accuracy? Remember, the friction forces are a fraction of any force that you apply in the Z-axis. The support hand should not exert any big force perpendicular to the handle of the gun that is on the Z-axis. The support hand should exert the major force on the back strap of the gun pointing forward, while the fingers on the front strap should be exerting the major force pointing backwards. Remember, the recoil is on the XY plane only. Notice that the forces shown on the graph are the sum of the forces, like when the fingers exerting individual forces on the front strap, we show the resultant or sum of those forces. Same thing with the hands exerting forces in the back strap. Any force perpendicular to the handle of the gun with the intention of producing friction forces will be detrimental to the accuracy. I repeat, any force by mistake of the shooter in the Z axis will be detrimental to the accuracy. So concentrate in applied forces on the front and back strap of the gun, and don't apply any force in the Z axis. If you want proof of this statement, put a vise holding the pistol in the front and back strap of the handle, and you'll see that the pistol will not move. I sincerely hope that this helped you to clearly see the way that you should hold a gun. Now I'm going to try to show you the exact way to hold the gun. The shooting hand high on the tank, like we said before, and the support hand should go halfway under the shooting hand, exerting the force forward on the back strap. The finger of both hands around the front strap. And this is another view of the left side of the gun. The right side, another view of the strong hand and fingers with the index finger pointing forward. I would like to recommend the manufacturers of pistols to make the handle a little larger. That way, shooters can improve the way the pistol is held, the accuracy, and put some more bullets in the magazine. I am going to strongly recommend a video that complements my video and is done by a police instructor, which does not have an analysis of the forces, but has very interesting things that you should know. The pistol is in YouTube and is called I want to say that I don't know that guy and I don't get any benefit from this recommendation. To end this video, I would like to challenge anyone that does not agree with this way to hold a pistol to go on a video with me and we will discuss it further. It's time to put an end to the wrong way to hold a pistol.